Hi, we've got a couple questions people have been asking about these labs, and they weren't really super easy to answer over email. So let's start with the first problem a lot of people had was they weren't doing the new data set. So remember, each lab I worked example data, but you were to work your new with the new data set. So the most common question seemed to be about labs 11 and 12, 11 and 12, maybe a little bit on 13, but I don't think anybody quite had gotten to that. The pre-labs aren't too bad. There's a quick picture if you want to. Quick. Okay. And all right, so the lab 11 gas concepts, it was a little bit involved in the calculation. So let me pull out our data for lab 11, our gas concepts. Um, Here it is. Okay. So we're going through these calculations here. So it started off with the massive magnesium. So everybody should have their lab book ready. Let's move my coffee around. So let's get an idea of what we're doing here. So let me get my view up so I can see what you guys are seeing. Okay. So here we go. We're looking at our magnesium. We were to start with magnesium. Here's our data set with magnesium was 0.040 grams. Room temperature was 294 Kelvin. Vapor pressure of water that we were at was 18.7 millimeters mercury. Barometric pressure was pressure was 1.001 atmospheres, and they said V1 was 36.10 milliliters. All right. So let's start with our calculations here then. So they gave us, the only thing they didn't give us was this pressure of dry H2. And so that's our P1. And that was the one we had to use Dalton's law of partial pressures. And so we're going to take the barometric pressure, 1.001, and we'll subtract from it the pressure of the water, which was that vapor pressure, 18.7, but that's millimeters mercury, and this was ATM. And so we need those in the same thing. So 18.7 millimeters mercury. Let's go ahead and just work this out. 760 millimeters mercury is 1 ATM. And so we'll go ahead and divide that out. 18.7 divided by 760. And so when I'm up here, instead of putting my 18.7, I could just put divide by 60 there, but I'm going to put 0.0246. And I'm going to go ahead and do 1.001 minus, and I'm going to just use that answer so I get my rounding. So my P1 in atmospheres is 0.976. I'll write it bigger too. 0.976 atmospheres. Okay. Then it asked for, we've got V1 that was given. So the next big calculation that we need is the experimental volume corrected to STP. So we've got P1, we've got V1. This was T1, this room temperature. So as long as it was in Kelvin, then we're okay. And so we're going to STP. And so we're going to do T2 will be 273 Kelvin, and P2 will be 1 atm. And if I pull out a list of my gas laws, I'm using, there's a very bottom one down here on this list, which is the combined gas law. So P1 V1 over T1 equals P2 V2. Trying to get this in before the storm hits, so apologize for some of the speed, but we want to get this up for you as quickly as we can. So we'll move that over here. P1 V1 times T2 will be P2 times T1. All that's my V2. And so pressure 1 was 0.976. V1 was, I'm going to go ahead and we could take it to liters, or we can keep it as milliliters. We'll leave it as milliliters, 36.10. And T2 was 273. And the P2 was 1. And T1 was 294. 0.976 times 273 times 36.1 divided by 294. 32.72 milliliters would be our corrected volume. Alright. So I'll just leave it at 32.7 since we've got 3 sig figs up there, so 32.7 milliliters. So now if I take this and figure out percent error, we have 36.1. So percent error will be the 36.1 that we got minus the 32.7 we should have got. Don't forget absolute value in parentheses on the top, and 32.7 on the bottom, and times 100. 6.1 minus 32.7, 3.14 divided by 32.7 times 100. What am I missing? Oh, no, I shouldn't use this number. I need to use my theoretical number. So that's not the right number there. We need the theoretical. We skipped that step. So the theoretical from the calculations. All right, so that came from our magnesium. So I'm going to get rid of some of these pressure calculations. I'm going to keep that 32.7. I think I'll come back and I'll rewrite that. Now, actual was 32.7 milliliters. Our theoretical, how much we should have gotten, depends on how much magnesium we started. So we had 0.040 grams of magnesium. And we're going to go for each 1 mole of magnesium. It's 24.31 grams. And it was 1 mole of magnesium to 1 mole H2. That's from our equation, magnesium plus H2 goes to MgCl2. Nope. Magnesium plus 2HCl goes to MgCl2 plus H2. There we go. So it's 1 magnesium to 1 hydrogen, and then at STP, 1 mole of any gas at STP, it's 22.4 liters. And I'm going to go ahead and take 1 liter is 1,000 milliliters. All right, and so we'll type out there in 0.04 times 22.4 times 1,000 divided by 24.31. I got 36.86 milliliters. That's our theoretical volume. All right, so now I'm going to use that for my percent error. So I'm going to do this bottom part, and we'll have 32.7 minus 36.86. Remember, we're doing absolute value over 36.86 and times 100. 32.7 minus 36.86 divided by 36.86. I got negative, and then times 100. You're going to ignore the negative, so it'll be 11.29 or 11.3 would be fine percent error. So those were the calculations that we needed on that. We just did one trial, so there we go. Okay. Looking real quick at lab 12 before we lose power. That was our acetic acid and vinegar. The calculations that we had on this, we had, let me see what I had here, 0.10. No, we had 0.01 milliliters initial for vinegar and 15.18 milliliters final. So I can go ahead and calculate that. It'd be 15.17 milliliters used. This is volume of our acid, VA. The sodium hydroxide was sort of 0.21 milliliters and ended up at 24.30 milliliters. So 24.3 minus 0.21, 24.09 used, so 24.09 milliliters used. That's the volume of our base. And the molarity of that base was 0.50. And that's it. So this is capital M. So it was 1-to-1. So MAVA equals MBVB. And we're going to keep these in milliliters, it'd be just fine. And so molarity of the acid is MBVB over VA, which would be our 24.09 times 0.5 divided by 15.17. Okay, 24.09 times 0.5 divided by 15.17. Now I got 0.794 molarity. And that's it. That's all there is to it. And so we were doing a whole bunch of extra. Probably you were doing the wrong data set, or you were overthinking things. So not too bad. 13, like I said, we had an example data set, which you wanted to really start it. And here comes the storm. I'll try and get this uploaded to you. I'll also be adding in some more attempts. Remember, next week's the last week to get these in, even though it's set for due tonight. I'll adjust that a little bit, but I still plan to grade them all the way up until finals week. All right. So see my announcement on when the actual due date is, but I'll get this uploaded and Hopefully it helps you out.